This is section 4.8, and we're going to discuss radical equations and power functions. And the first thing that we see in the lecture notes are some properties of rational exponents. And we should know those coming in, but if not, we'll just review them. And here's the actual property which they use with letters B and R and P. And here's some examples that may make it a little clearer. So if we look at this one, b to the m over n, so that's like a fractional exponent. You can make that b to the m to the 1 over n, or b to the 1 over n to the m. You can break it apart if you need to. Over here, 4 to the 3/2 is the same as 4 to the 3rd to the 1/2. And so if we know that 4 to the 3rd is 64, and 64, the square root of 64 is 8, we could go that way. Or you could say that's also 4 to the 1/2 cubed, and 4 to the 1/2 is 2, and 2 cubed is 8. You could do all that without a calculator. Let's look at this one. B to the R to the P, whenever you have power to power, you multiply them. So if you had 2 to the 3/2 to the 4th, that's 2 to the 3/2 times 4, which would be 2 to the 6th, which is 64. If you have a negative exponent, it changes the position. So this B goes to the bottom of a fraction. If the negative exponent's here and you want to make it not negative, it comes to the other position. So it's a change in position. 4 to the negative 1/2 is 1 over 4 to the positive half. And this 1/2 is always the square root. So square root of 4 is 2, so that's equal to 1/2. If you are multiplying expressions with exponents, you add the exponents if the bases are the same. If you are dividing and the bases are the same, you subtract. So all of those examples are there, and we'll have some of those questions that refer to these properties within our problem set. Then the other thing that we want to practice is solving an equation that contains a square root. So if our original problem is x equals the square root of 15 minus 2x, your first step, you got to get rid of the radical, so we're going to square both sides. So that leaves x squared equals this thing squared. When you square a radical, you're left with simply what's inside. So we have x squared equals 15 minus 2x. We're going to move all the terms to one side so that we have it equaling 0. With a quadratic, we always want to do that. Then we can factor this part. That factors to x plus 5 times x minus 3. This gives us x equals negative 5, and then we get x equals 3. We do have to check or test each answer. So if we take negative 5 and we put it back in the original equation, we've got negative 5 equals the square root of 15 minus 2 times negative 5. That becomes 15 plus 10. That's the square root of 25. Negative 5 equals the square root of 25. Negative 5 equals 5. That's not true. That becomes an extraneous root. The 3, when we plug it in, 3 equals the square root of 9, 3 equals 3. Check, that one works. So anytime you're doing radical equations, be sure you check it because one of your roots could be extraneous. Okay, let's go look at our problems. Okay, on these, you can do them on your calculator or by hand. If you're doing this by hand, this 49 to the negative 3/2, the square root of 49 is 7. 7 to the negative 3 is 1 over 7/3 equals 1 over 343. But I want to show you on the calculator how we can do this as well. Pretty easy. Let's get out of the graphing mode, and if we just put 49 raised to parentheses negative 3 divided by 2, and we hit enter. What happened there? Let's check that out. So when you do your calculator ones, you're not going to get a fraction most of the time. So we got this crazy decimal, but if you just hit math and the first option is fraction, it turned into 1 over 343, which is what we got here. So either way, you can do it on your calculator or not. If the next one, let's do negative 36 raised to the 0.5, and oh, I didn't clear. Okay, let's try that again. Negative 36 raised to the 0.5, and we get the -6. If we were doing it by hand, it's negative 36 to the 1/2. So this negative is outside, and then the square root of 36. 4 to the 3/4 squared. Remember, you multiply these, so that's 4 to the 6/4, 4 to the 3/2. You take the square root of 4, this bottom denominator, you take the square root of 4, which is 2, and then you raise it to this power. 2 cubed is 8, or you could do it all in your calculator. This says evaluate by hand. Remember, if you have the bases the same and you're multiplying, you add these two. So that's 216 to the 5/6 minus 1/6. That's 216 to the 4/6, which reduces to 2/3. The cube root of 216 is 6, and 6 squared is 36. All right, number 5. 5/6 to the -3. When you have a fraction to a negative exponent, you can flip the fraction, and then the exponent is positive. So that's 6/5 cubed. So you can cube 6, get 216, and cube 5, you get 125. So there's that answer. Rewrite with a rational exponent. There's an understood 1 here, even though it wasn't written originally. So this is 7y to the 1/7. The number in here is your numerator, and then the number here is your denominator. Okay, let's look at number 7. 6th root of y to the -5. We can put all of this under 1. 1 over 6th root of y to the 5th. So that is 1 over y to the 5/6. Remember, this number out here is the numerator of your fraction. There's your denominator. Use radical notation to rewrite. We have c to the -3/4 times d to the 1/2. That is 1 over the 4th root of c cubed. That's this one. Times the square root of d. Okay, so we've got square root of d over the 4th root of c cubed, and you really can't do much more than that. If possible, evaluate the function at the given value of the variable. So they say, this is your f of x, and let x be 4. So the cube root of 5 times 4 minus 12, well, that's 20 minus 12 is 8, so that's the cube root of 8, which is 2. Evaluate this one for x equals 4. The third root of 4 cubed. 4 cubed is 64. The cube root is 64. We're going to get this right. This is 3 times the square root of 64. Square root of 64 is 8. 3 times 8 is 24. Now, transformations of y equals the cube root of x to graph this one. y1, you can put it in. Let's go do it in the calculator. Okay, so we're in y equals, and we're going to put the cube root. And to get the cube root symbol, we go to math and choose number 4. That's cube root. If it's any other root, you can use 5, but we just need cube root, so we'll put that there. and it's the cube root of negative 4x. And let's do, that looks like a normal window. We're going to do a zoom 6 for standard. And we can see that that matches our C choice right there. So those are easy to put in, and in the lecture notes, I have put to get cube root, use math 4. Number 12, fourth root. So let's see what that looks like when we do that. So we go back to y equals, we're going to clear, and we're going to go to math, and we're going to choose 5. And you have a box up here for the root, so that's the fourth root. And then we'll just tab over to x plus 1. Put that in. Then we'll do another tab to get out of the radical, and we'll do minus 4. So that looks like we have matched that right here. Let's hit, now this is a little bit smaller on the graph, but let's see if we can tell by just zoom 6. So, yeah, it'd be this one down here. But if we wanted it to look exact, we could change the window to all 6s, but I think we can tell from that that's that one. And I have it here. All right, 13, solve the equation. Remember how we had to do this. We had to square both sides. So here's our beginning. We square both sides. That gets rid of that radical. This one is x minus 5 squared now. So we go ahead and do that, and we get x squared minus 10x plus 25 equals x minus 3. We're going to subtract x. We're going to add 3. So now here's our quadratic that we want to solve. We get x minus 7 times x minus 4, which gives us x equals 7, x equals 4. When you test them, 7 works, 4 does not. We come up with square root of 1 equals negative 1, which is not true. So we discard that one. Only put the 7 in your answer box. Cube root of x plus 8 equals 2. So now instead of squaring both sides, we're going to cube both sides because we have to get rid of this cube root. We get rid of the radical there, so we have x plus 8 equals 2 cubed. 2 cubed is 8. Subtract 8, and you come up with x equals 0. So we solved some radical equations. We did quite a few things with radical to fractional exponents and back, and practiced some with our expressions. So I think that'll be good for 4.8.